All right, this is for assignment 10 in geometry, and what it's going to cover is trigonometry. Just the very start of trigonometry. Don't let this, just because trigonometry, every time somebody hears it, they think that it's going to be too hard for them. It's not that difficult, and we're going to take it sort of slow and just do basic stuff this first lesson, and then we'll go on to some a little more difficult stuff, or stuff you actually have to do a little more work for. So today all we're going to do is find trig ratios. Remember, a ratio is normally just something like 3 to 5, so 3 over 5. Find parts of triangles. We're not going to do a whole lot of that today. That's going to be the next lesson. And solving problems. Actually, we're going to do a little bit of this. We're going to find some angles. And then solving problems using the trig ratios. That's going to be the next assignment, or the one after that also. So trigonometry, the basic parts of trigonometry are the sine, cosine, and tangent. On your calculators, you have these buttons on here that you probably noticed in the past. Say sine, they say SIN, COS, TAN. That's the sine, cosine, and tangent buttons. There's a saying, SOHCAHTOA, SOHCAHTOA, to help you remember this stuff. And all this saying is sine means opposite leg over hypotenuse. And I know this doesn't make a whole lot of sense right now, but it will in a few minutes. C stands for cosine, and that means adjacent leg over hypotenuse. T stands for tangent. That means opposite leg over adjacent leg. Remember, these are ratios, and what it is, instead of what we've been doing, using Pythagorean's theorem, dealing with right triangles and knowing two sides and finding the third, and we also did similar triangles where we matched up the triangles and set up proportions. Well, what somebody realized a long time ago is, if you have certain right triangles, then there's always certain right triangles that are similar to each other. So they always have the same ratios when you match up the sides. So when we were matching up the sides with the similar triangles, and you were saying, 4 matched up to 12, the same as X matched up to 15 or whatever. When we did that, now they're saying, all right, if it's a right triangle, and these trig ratios only work for right triangles, if it's a right triangle, then we don't need both of these, because we can use the basic ideas that are already implanted in this calculator and on a chart that I'm going to show you here in a little while to set up equations. So we only need one triangle instead of two separate triangles. And the ratios are, the sine ratio is always the opposite leg of the triangle over the hypotenuse. The cosine ratio is always the adjacent leg of the triangle over the hypotenuse. And the tangent ratio is always the opposite leg over the adjacent leg. And again, I know that doesn't make a whole lot of sense yet, but we're going to label triangles and do stuff, and hopefully it'll make more sense. Just another thing, SOHCAHTOA, just use that SOHCAHTOA to try to help you remember. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent is opposite over adjacent. So it's just sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. So these are what the equations look like when we're doing this. Each time you're going to set it up, you're going to say the sine of some angle in that triangle, in that right triangle. Remember, these always have to be right triangles. Some angle, here I just put angle A. If we want the sine of angle A, it's always going to be the opposite leg over the hypotenuse. And this is going to be our equation. We're going to know, maybe we know the angle, and maybe we know the opposite leg, and we're going to be trying to find the hypotenuse in. We're going to know two of these three parts in each one of these. Cosine of angle A is the adjacent leg over the hypotenuse. Tangent of angle A is the opposite leg over the adjacent leg. And we're going to set up these equations and solve for the missing part, the part that we don't know. So the first thing you got to do every single time when you're doing a problem that deals with these trig ratios is you must label your triangle first every single time. On the right triangles, I was always saying, write in hypotenuse on the side across from the right angle. Now you have to write this stuff in so that you know which trig ratio you're dealing with, whether you're dealing with sine, cosine, or tangent. You have to write this stuff in. So the first thing you're going to do is you're going to figure out which angle you're dealing with. Here they put this arc in here, so I'm guessing we're dealing with angle A. You're never ever going to be dealing with the right angle. It's either going to be angle A or angle B, so don't ever pick the right angle. You pick one of the other two angles, one of the two acute angles, because in a right triangle these two other angles are always going to be acute. And if it's angle A, I'm going to label it just like this. I draw in this arrow. That side across from angle A is called the opposite leg because it's opposite angle A. The side across from the right angle is always labeled the hypotenuse. And then the side that's hooked to angle A, which is the other leg, it's hooked to it, so hopefully you remember that adjacent means hooked to. So that this is the adjacent leg. Now when you go to label these, I don't want you to write out all of this stuff every single time. So if you have a right triangle, and let's say we're dealing with this angle this time, when you label it, you could just write opposite hypotenuse, and then this third side then is usually the hardest one to figure out, is the adjacent. So opposite is across from the angle you're dealing with, hypotenuse is across from the right angle, and adjacent is the one that's hooked to the angle that you're dealing with. That's not the hypotenuse. So every time you see a right triangle, we're dealing with this angle maybe, that's your opposite leg, you're just going to label it opposite. That's your hypotenuse. That's your adjacent. Over and over and over again for all this trig stuff. First thing you got to do every single time, label the triangle. And that's all I did here was I labeled it, drew in the arrows, opposite leg, hypotenuse, and then the adjacent leg is the one that's hooked to the angle that we want to deal with. To find the sine, cosine, and tangent of an angle, all you're going to do is pick the angle. We're never ever going to pick the 90-degree angle. Now I put some problems on the assignment that actually did pick the 90-degree angle just so you can see it. But as long as you're picking, you're not going to pick the 90-degree angle. Label the triangle with opposite, adjacent, and hypotenuse. And then write the ratio. Some of the problems that we're going to do today, I just want you to write the ratio as a fraction. So it might be one side is 12, the other side is 32. And you're just going to leave it as that ratio. That's your answer. Second part down here, and I'm going to go over these. We'll do some of them separately, but these are two different ways. If you know the angle measure, use the calculator or the chart. I'm going to show you the chart here in a few minutes. And all you do is you punch in sine, cosine, or tangent, whichever one you're dealing with, the angle measure, and then you just hit enter or equals, and it's going to tell you your answer. And I'll do some of those problems here in a couple minutes. So for angle A, if I'm looking at angle A, again, opposite leg, drawing the arrow, the hypotenuse is across from the right angle, adjacent leg. Now notice, then I do it for angle B for that same triangle, and notice what changes. Now I'm dealing with angle B over here. Opposite leg's over there, the hypotenuse stays where it's at, and the adjacent leg. So for angle A, one angle in this triangle, and then angle B, the other angle in this triangle, the opposite leg and the adjacent leg switch places depending on which angle you're dealing with. So if I'm doing this, find the sine, cosine, and tangent of angle A. First thing you might have to do, which I have to on this one, sometimes you won't have to because they'll give them all to you, but you might have to find this third side. Alright, and we could use Pythagorean's theorem, make this x if you wanted, and use Pythagorean's theorem and say x squared plus 12 squared equals 13 squared, and solve that. Or maybe you remember, hey, there was a Pythagorean triple that was 5, 12, 13. So if this leg's 12, the hypotenuse is 13, then that means this other leg has to be 5. So this number right here is 5. And if you did Pythagorean's theorem to find that missing side, which you're going to have to do on some of the homework, if you use Pythagorean's theorem, you'd come up with 5. If I did this, x squared plus 144 equals 169, subtract 144 on both sides, just Pythagorean's theorem that we did a couple of assignments ago. 169 minus 144 is 25. Take the square root of both sides. You end up with x equals 5. So either way, if you remember the Pythagorean triple or that. Now for sine, remember sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, the SOHCAHTOA, and tangent is opposite leg over adjacent leg. And we're just going to figure out what each of those ratios are for this triangle. And what we know with these right triangles is the fact that every other triangle that fit into that 5, 12, 13 family is similar to this triangle. Whether it's bigger, smaller, whatever, they're all similar. So all these ratios are going to be the same. It's like the scale factor for this certain family of triangles. So first thing I'm going to do, if I'm dealing with angle A, that's this angle, I want to label this triangle. That's the opposite leg. Side across from the right angle is the hypotenuse. And then the other side that's hooked to angle A is the adjacent leg. And then all you're going to do is take the numbers and put them in these ratios for each one of these. The SO part, sine is opposite over hypotenuse. So opposite is 12. The hypotenuse is 13. That's the sine of angle A. 12 over 13. That's all there is to it. You don't have to change it to a decimal or anything for this certain problem. That's just the way it is. The cosine is adjacent over hypotenuse. So it's 5 over 13. Then the tangent's opposite leg over adjacent leg. So the opposite leg for angle A is 12. The adjacent leg is 5. Those are our three answers. Sine of angle A is 12 over 13. Cosine of angle A is 5 over 13. The tangent of angle A is 12 over 5. And again, a lot of this probably doesn't make a whole lot of sense. But we're just doing a part at a time. So just doing a little part to lead you into being able to use this stuff to actually find different things. So the first part is finding those ratios. 12 to 13, 5 to 13, 12 to 5. We got the same triangle here, so we know that this side over here is 5. 5, 12, 13 again. This time we want to deal with angle B, so that's this angle. So I'm going to label the triangle in relationship to it. So that side's the opposite leg. That's the hypotenuse. And then this side is the adjacent leg. For sine, that's the so part. Sine is opposite. Sorry, can't see that. Opposite over hypotenuse. So opposite, which is 5, over the hypotenuse, which is 13. That's our sine for angle B, 5 to 13. I'm going to write cosine out here a little farther so I don't run into that. Cosine, that's the c part. Cosine is adjacent over hypotenuse. The adjacent is 12. The hypotenuse is 13. So 12 to 13. And then the TOA part of the saying, so, ka, TOA. The TOA part is tangent equals opposite over adjacent. Opposite this time is 5. Adjacent is 12. That's our tangent for angle B. And you'll notice we have our angle B and our angle A. And you'll notice that the sine and cosine for the two just switched what they were. And then the tangent is the reciprocal of each other. So the number that's the tangent of angle A is the reciprocal of that is the tangent of angle B. And that's what happens every time when you're dealing with that one certain triangle and just dealing with the two different acute angles in that certain right triangle. Alright, so that was this first part. Now the second part, this we're going to use our calculators for. If you don't have a calculator, if you don't have one of these two especially, if you have the Casio or whatever, it'll still work. It has to have those 3 buttons on it. It has to have the SIN button, the COS button, and the TAN button. So you find those buttons on the calculator, you're going to use them. Again, make sure it's in degrees. Make sure your calculator is set up from the mode button or the setup button or whichever button it is for your certain calculator, and that it's in degrees. So what we're going to do is we're going to put in sine, cosine, or tangent, put in the angle measure, hit enter or equals, and that's going to give us our answer. It's that simple. So if I take this, if I'm using a big calculator, and let's say I want the cosine of a 52-degree angle. Just pick a number at random. I'm going to take this calculator. I'm going to clear all that off. And all I'm going to punch in is I'm going to hit the cosine button. Notice it pulls up COS, then a parenthesis, and you just put in your angle, which is 52. Hit equals, and it gives you the cosine. All of these answers we're going to round off to 4 decimal places, and that's what it says to do on your assignment. You're going to go out 4 decimal places, so we're going out to the 10,000ths. So 0.615, then we got a 6, but that other 6 tells us round that up to a 7. So 0.6157. That's our answer. That's the cosine of a 52-degree angle. Now, I know that's not a ratio. It's not written as a fraction anymore. But what they've done to fit it into your calculator is they've changed that ratio, like we were getting over here, the 5 to 13 or the 5 to 12 or 12 to 13. They've changed that into a decimal form so it is easier on the calculator. So that's the same thing, only it's written as a decimal form instead of a fraction form. If we have this calculator, turn it on, hit clear. You're going to do the same thing. You hit the cosine button, and it looks exactly the same. 52, hit enter, and it tells you 0.61566. Same thing the other one told us. We round that 6 up to a 7, and we get the exact same answer. I got the Casio calculator. I hit the cosine button. It looks exactly the same. Put in 52. Hit equals. It gives me the same answer, 0.61566. I round that first 6 up to a 7. So either way, this is the ratio for every single right triangle. If I have this right triangle right here, and it's got a 52-degree angle in it, the cosine, that's the part, that's the ratio of the adjacent leg, which is hooked to that 52-degree angle, and the hypotenuse. For every single right triangle in the world that's also got a 52-degree angle in it, that's the ratio of these two sides to each other. If you have one of these calculators that doesn't print across the screen, then what you have to do that's a little different, you got to listen closely to this, if you have one of these smaller calculators, is you have to punch in the angle first, then you hit the sine, cosine, or tangent button. So you punch in the angle, then you hit sine, cosine, or tangent. Some of the calculators too, some of them, I can't remember which ones they are, it might be a Casio. There might be a trig button on it. You just have to find it. And if it's got a trig button, you push that trig button, and then it pops up sine, cosine, or tangent, and you have to just tell it which one you want to use. So then you have to select from that. So some calculators have that trig button. You push the trig button, then you go to sine, cosine, or tangent, then punch in your angle. Another way you could do it, if you don't have a calculator, is this chart. And I know you can't hardly see this chart, but this is what I used back in the dinosaur days when I was doing this stuff and we didn't have calculators. This chart has it all printed out. What if we look at 52 degrees? If I go over here to 52 degrees and we did the cosine, that's the second column. It says right there, it says 0.6157. So it's got it all printed out. This whole chart is stored in your calculator. So you could use this chart to find each thing just by matching up the angle, whatever angle. Let's say we want a 10-degree angle. We go down to 10 and we want the sine of it. We go over to the first column, which is sine, and it says 0.1736. If we want the cosine, we go over to the next column. If we want the tangent, we go over to the next one. So angles, sine, cosine, tangent, and then higher angles, 45 and up, sine, cosine, tangent. And you'll notice down here, for tangent of a 90-degree angle, it's got some little crazy infinity symbol, sideways 8. It's actually undefined. You can't find the tangent of a 90-degree angle, and that's why we don't pick. You'll notice here for tangent, you got 1, you got 0, and you got infinity. That's why we don't pick the 90-degree angle. We pick one of the other two angles to deal with. So let's just do a couple of angles here real quick. If we wanted to do the tangent of a 30-degree angle, you grab your calculator. I'm going to use this one to show this time. And you just hit the tangent button, 30 degrees, hit enter, and you write down 4 places behind the decimal. 0.5774. Sorry, I rounded wrong. That's your answer. If I wanted the sine of 82 degree angle, I hit sine 82 and it gives me 0.990. We'll round that up to 3. If you're one number off down here at the end, I'm probably not going to count it wrong. If you rounded wrong or whatever, you're pretty close, and it's going to be a pretty close answer since we're going out so far. If I use the big calculator, and let's do tangent of 87 degree angle, hit tangent, TAN, 87, enter. Notice here it says 19.0811. Everything else that we've gotten so far has just been decimals, no whole numbers in front of the decimal. Tangent is the only one of the 3 ratios that can ever be larger than 1 whole. So it's the only one that's ever going to have a number that's not a 0 out in front of the decimal. Sine and cosine must be less than 1. So it's got to be like 0.9999 whatever, but it can't have a number out in front of the decimal. Tangent can, sine and cosine cannot. Alright, if you're finding an angle, and we could have used that chart also on those last ones. Maybe I should say that. If you don't have anything, let's say tangent 87. If I go over here, find the 87 degree angle, which is way down here, I go over to tangent, you'll notice it says 19.0811. Exact same thing that we got when we did it using the calculator. If you're actually finding the angle given the trig ratio, this is a little different. On your calculator, whichever one you have, you're going to do these 3 steps. You're going to hit the second button, which on my calculator is the blue button right here. If you have the red calculator, then it's this or yellow button or whatever color it happens to be. On most all calculators, it's right there in the corner. On the Casio, it's the shift button. It's not the second button, it's shift. So you're going to hit that button, second or shift, whichever it is. Put in the trig ratio. That's either the decimal, the fraction, or whatever it gives you. Alright? So it's like we're working these problems backwards. Now instead of knowing the angle, they're telling us the trig ratio, and we're trying to find the angle. So if we were on the chart, we would know this number in here, and we would use the chart backwards to find what angle we're dealing with. Hit equals or enter, and that's going to tell you the answer. So if I do a couple just examples here, we'll do one that we just got done doing, tangent, and we'll call it angle A. These are written many different ways. I'm going to show you all the different ways that they're written. So it could say the tangent of angle A is 0.5774. We just got done doing this. What you're going to do is you're going to type into your calculator. Let me hit clear. You're going to hit the second button. Then you hit the trig ratio that we want, which is tangent. And you'll notice on the calculator, it pops up tangent -1 parenthesis. This -1 is telling you that you're doing the inverse, or the opposite of what you want. So in other words, you're using this chart. You're telling the calculator, hey, I want to use this chart, but I want to use it backwards. So I want to start here and go out to the angle. That's what that means. So anytime you see that -1 on something, that means the inverse, or the sort of the opposite. And I just punch in tangent, and or second tangent, then I put in the number 0.5774, hit equals, and we're going to round most of our angles off to the nearest degree. You'll notice this one comes out to be 30.002. That's the same thing we just got done doing. The tangent of 30 was 0.5774. So that's telling us now that angle A, the measure of angle A, is about 30 degrees. That's what we're doing when we're doing that backwards. When we're hitting second first and doing that. So we're trying to find the angle. That's what we just did there, was found the angle. If I do it on using the red calculator, let's doesn't matter, tangent of angle Q. Let's not do tangent, we just did that. Cosine of angle Q equals, I'm just going to make up some random number here, 0.2486. I hit second. Cosine. Notice it does the same thing. It pulls up cosine -1. I put in this number, and the calculator is going to tell us what the measure of that angle Q is. So 0.2486. And it says 75.6. I'll be okay with just round that to the nearest degree. So we'll say angle Q, the measure of angle Q, is about 76 degrees. So we have some angle in a right triangle. Got your right angle, and we got some angle Q here. And we just figured out from this ratio, from that decimal, that angle Q's got to be 76 degrees. And once we find what angle Q is, we could find this other angle, because the three angles of a triangle have to add up to 180, and so on and so on. But that's what we're finding, is that angle. We have the Casio. Let's try one using the Casio here. Say sine of angle B equals, let's do a fraction, 3/10. Just made up something. It doesn't matter if it's a decimal, fraction, whatever it is. We can put that in here. So on my calculator, I'm going to hit clear, get rid of all that mess, and we want the sign, so I'm going to hit on the Casio, I'm going to hit shift. On the other calculators you hit second. Sine, notice it pulls up the same thing, sine -1. And we punch this in, 3 divided by 10, close the parenthesis. It'll do all that for you. It'll take care of that fraction, and it tells you 17.45. So I would probably round this one off, since it's right there in the middle. I'd probably just round it to 17.5 degrees, or 17.5 degrees. The other ways that they could write these, so I did one like this. The first one there, tangent of angle A equals some number, whatever that number is, 0.4628. It could also be written this way, tangent and then it will have the -1. So tangent, the inverse of it's what it's telling you. So it's saying you're doing the inverse tangent there, and then it'll have the number here, maybe 0.4628. So instead of having it written out this way, it'll just say what your calculator is going to show you, or it's showing you exactly what to punch into the calculator. Second, tangent, and then you put in the number. So these two mean exactly the same thing. You're doing the same thing on those. Another way it could be written is it might be something like sine, and then it might have something like square root of 3 over 4. Still the same thing. You take your calculator, I wrote that wrong. It's going to have a -1 in there, and then the parentheses around that. Or it could say sine of some angle equals radical 3 over 4. So just a different form here using the radical in there. And whenever you're doing it, it's the same for either one of these two. So I'm going to hit second, sine. Notice it pulls that up, and then you just put this into your calculator inside those parentheses there. So we hit second square root 3 divided by 4, close the parentheses. So it looks just like this. It equals, and it tells you that the angle is a 60-degree angle. This one, same idea. You're going to hit second sine, put that into your calculator, and it's going to tell you it's a 60-degree angle. Things to remember: sine and cosine always got to be less than 1. So if you're doing something and you figure out that the sine of angle A is 3.6284, yeah, you did something wrong. Or it's probably not that you did something wrong. It's probably that your calculator is in radians and not degrees. Tangent can be any number, so it can be bigger than 1. Last thing here, and this is what we're going to deal with next time, so not a whole lot about this on there, but if you're given a right triangle and we're actually trying to solve part of the right triangle or find part of the right triangle, let's say we're trying to find that side right there. First thing you're going to do, you're going to pick an angle. So maybe we pick angle A. You're going to label the triangle opposite leg, hypotenuse, adjacent leg. Then you're going to write an equation. Now I didn't put any numbers in mine, but your equation is just going to be the trig name, so sine, cosine, or tangent, whichever one. The angle, if you know the angle, then you're going to put the number in there. If you don't know the angle, then you're going to put like angle A in there. Equals, and then the ratio. Well, this ratio would be the opposite leg over the hypotenuse. So you're going to have numbers here, here, or here. You're going to know 2 of the 3 numbers. And then you can solve that just like you would solve any other algebra equation. There's a couple of problems on the homework that deal with that. I just want you to try them. We're going to go over that more next time. If you have questions with your calculators, please let me know. So you could text me, email me, call me, whatever. If I didn't explain how your calculator works, then get a hold of me and I'll explain how it works so that you can do this stuff. Don't make this harder than it is. The assignment is like 50 problems long, but they're real simple. The first page has got 22 problems on it. It'll probably take you all of about, because you're using your calculator on all this, might take you all of about 10 minutes or so to do the first page.